In this video I'll be continuing with the C# video tutorials. So in this video I'll be going over comparing structure objects. So I've already have like a Windows Form app up here. So I'll probably just take this out and do it again. We'll just declare another struct here, so I'll say struct automobile. So struct automobile, then here we'll just open a block. Then we'll assert them with public. Excuse me, so we'll insert them. We'll insert the fields with the public access modifiers. So here we'll say public, what do we have here? Public string make. Public int, what was the, I forgot what it was. Actually, let me just Control Z that to see what we had here. Okay, it was int year and double mileage. Okay, so int year, double mileage. We'll have public string, public int make and public double mileage. Oops, sorry, public int, what was it again? Make. Model, I think this was model, was it model? No. Oh, no, this was year. Okay, so public string make, public int year, and public double mileage. So our automobile struct has 3 fields. You can also add methods to your struct if you want, but after we do classes, the docs recommend to just create methods in. If you really need to, you can create them in the struct, but they recommend just to create class objects, or like class methods. Okay, so you cannot perform comparison operations directly on structure objects. For example, assume that, for example, car and truck are instances of automobiles, of the automobile structure. So we could create some instances of that. Take this out here. So for example, we could say that we have automobile. So we have an automobile object, which is going to be car points a new automobile. What's wrong with that? No, I spelled it wrong. Okay, so then here we could have private, for example, automobile truck points a new automobile. Now we can set the fields and all that. And let's just pretend that we had, I don't know, like public or private int. I'll just go with public. Let's go with like public int compare. We could say that it takes a automobile. Let's just go public void compare in this case because it's waiting for a return type. We could say that it takes a parameter automobile, so it takes automobile struct. We could say that it takes an automobile car and an automobile truck. Okay, what the heck's wrong with that? Compare, is it? Or reserved word already? No. I mean, is it a built-in method? What's wrong with this? Okay. Problems. Inconsistent accessibility parameter. Automobile. I think this might be a built-in method. Let's go with compare automobile. That gonna work? No? Okay, let's go with private then. There we go. Okay, so we can't create a public method like that in C#. So let's go with just compare. So it takes an automobile car and an automobile truck parameter. So we could say, for example, so if we go, so this is not going to work. So if we go if car is equal to truck, well, that's not going to compare anything. That's not going to work. That's going to cause an error. So you can't do that. So what can you do? In order to compare two structure objects, you must compare the individual fields as shown. So we'll do that here. So to do that, you go if car. Pretend we had all the fields set up. So if car.make is equal to truck.make and car.year points to truck.year. And it's a little tricky to do this, but once you get the concept, I know in every language comparing things can be hard. For example, in Java, to compare objects, use the compare to method. In C# it seems like you can just use the equal sign if you have the right, if you have everything set up properly. So here, so make year, and then we'll have, for example, if car dot mileage points to truck dot mileage. Then in that case, we'll say message box dot show autos are the same, whatever, or equal. But in this case, we don't have anything, so it might just not print out anything because we haven't instantiated those fields at all. We haven't set the fields. So nothing popped up because none of the fields were set. So let's set some of the fields. Let's go with car.make points to Ford. Let's go car.model points. Actually, no, not model. What else do we have? Car.year points to 2007. Let's go car.mileage points to. Actually, no, couldn't be a string. We go car.mileage, and we'll say that it points to. What does it point to? 7,000 kilometers. Or whatever. Then here we could also do the same thing for truck. We'll set everything the same. Okay, so then now let's run this. Actually, we never ran this method initially to start, so that could have been the problem as well. So here we'll go compare car and then comma truck, like that. That's how you do it. We'll just run that and see what happens. So it should say autos are equal, so that it did say that, so that's correct. Okay, so now let's move on to arrays of structure objects. So structure objects can be stored in an array. For example, we've already talked about this in the notes. So we can assume that the automobile structure exists once again. Then we could say, so we could then create an array of 5 automobile objects. So we could take this bit out. So we can go here. So we'll add a constant int field somewhere here. So we'll go const. We'll go constant int size points to 5. Well, actually, that's too much. Let's go with 3 then. Then we'll go with automobile array autos auto array or autos array points to new automobile, passing in the size or the instantiate them to the array to size object. So what do we do here? So we created a structure array and it looks exactly like a normal array, but look what we did. We changed the type here. We took this array. Alright, it's pretty confusing, I'm not gonna lie. Because it's working with creating types, object types in a way through structs, which you can do with classes, which we'll show later on as well. But pretty much you can, so all you do is we're saying, okay, let's look at a normal array instantiation. We go private int array points a new int array of, for example, size. Can you see the similarities and differences? What's similar and what's different? Well, what's different is that, well, let's talk about what's similar. So we have similar is we have the private access modifier, which you don't need. What's similar is we have the array beside the type. We have the array like symbols or the boxes beside the type. The array brackets beside the type or object type. Then we have the name, which is the same. You have to name or create an identifier for your object. Then here we use a new keyword, that's the same. Then here we have the int, so we have the type here again. So the only thing that's different is the types, because for the size allocation we used size in the array bracket, so same thing. So all we did is we used our struct as a type. As the array type instead of, for example, int. So we use the struct object as the array type instead of int. So when you create a structure array, each element of the array is a structure instance. So now, in this automobile array, each index is an automobile object which has these 3 fields. So it's really confusing because you have this index in here, which is an object, which branches into 3 other indexes pretty much, or just fields. So each index here has 3 fields. It's a pretty tricky concept, and pretty much you'll probably get tested on this for sure. If you learned about structs a lot, you're taking a C# university class, your professor will probably test you on a struct array, because it's a hard concept. So when you create a structure array, each element, okay, so we already talked about that. Actually no, okay, so when you create a structure array, each element of the array is a structure instance, and the fields of each instance are initialized to 0. That's not true in all cases. So if any field is a reference variable or an object reference, then it is initialized to the value of null. So each index here, I think here we'd have 1 null for the string and 2 zeros for year and mileage. For everything. For all the data in the array at this time. Because right now we have 5 automobile objects in this array. Think about that. Imagine we have an array here, somewhere. And pretend each index has a car in it. Or it just has an automobile in it. Just think of an automobile, it can be anything. So an automobile, well, it can be anything. The compiler doesn't know that it cannot be anything. But you know that it can be, like in English terms, you know that it's like an automobile is like something that has a motor and it moves, pretty much. So pretty much here, in this case, we have 5 automobiles in this array, where each automobile has 3 fields, so the total fields of this array would be 15. Whereas, continued, the string field for all the automobiles would be set to null, and the other 2 fields would be set to 0 because they're number types, and one is an object type. So hopefully that makes sense. I know that's kind of confusing. So each element of a structure array may be accessed through an index, for example cars, or what do we call this? So autos array of array index 0 dot, you could set it, so we could just show that here. Oh, not yet. So for example, autos array of array index 0 is the first object or automobile object in the array. Autos array of array index 1 is a next, and 2 is a next, and so on. It's just like a normal array. To access a field of any element, you just call the index with the dot operator to access the field. So to do that, we'd go, for example, we have all this extra stuff here, which we don't need, I don't think. Okay, let's just keep them just in case. We'll take this one out. We'll take this stuff out. Okay, so what can we do here? We'll go autos array. So autos array of array index 0. What does each auto array object, or what does the autos array have? So it has make, year, and mileage. So make, year, yeah, so make, year, and mileage. So you could go dot make points to forward. You could go autos array dot, or autos array dot array index, or no, or so autos array of array index 1 dot make points to forward as well, or we could go forward as well. Yeah, we could go autos, or autos array of array index 0 dot year points to, I don't know, 2007. We could just do that. So pretty much you could access all the fields like that. So 1,000 miles on it. So that's pretty much it. That's how you access the fields. So we could do, for example, a for loop. So we could use a for loop to iterate through the, what do we call this, autos array, displaying the data stored in each element. So how could we do that? We could go, we could use a for loop, not a for each loop. So we go for I points to 0, I is less than autos array dot length property, and then I++. So use your standard for loop, and then we'll go message box dot show. We could say that we want to show autos, no, not as a string, autos array of array index I dot year plus space. Or we could go plus a tab. Is that gonna work? No, we have to do that in a string. Anyways, we'll just go here plus, and then we could do that, I think, but that's just gonna tab it out too much. Okay, let's just try it here. So let's just go with plus a tab plus autos array of array index I dot we forget, I'll just go with make then. Dot make plus tab plus autos array dot mileage, sorry, of array index I dot mileage. Which would be pretty much done. So that works. You can tab them out like that. You can add more stuff to the actual message box to show everything properly. So I'll just tell you guys what's in the Windows pop-up that's going to pop up. What's going to be in the pop-up window, we'll see. Whoops. Okay, so we have 2007 Ford with 1000. That's what it tells us. It doesn't tell us everything that we need to know, or that we would want to know as a user, but it's good enough. So we'll just go with that. Sorry, just spilled some water here on my cord by accident, which I knew was going to happen one day. Okay. So let's pray that the mic and the mouse don't go, or else the videos will be gone for a while. What was the rest? Okay, so it showed us the rest of the indexes with like zeros and tabs. And a null, I think, at some point. Okay, so that's pretty much it. You can also use a for each loop to iterate over the elements, over all the elements in a structure array. So let's do that as well. You will probably be asked to provide a for each loop because they always know everyone uses a for loop usually. Not always, but in most cases. You get used to the for loop. They tell you they probably used the for each loop a few times. Then they're like, okay, we're testing you on it. And it's always worth a lot too. It's like a big question. Okay, so here we'll go for each. For each we'll go auto. So what's our type? Our type is automobile. Let's say, what do we call this? Val. Auto val. In autos array. What do we want to iterate through? We want to iterate through autos array. Then what do we want to do? We want to say that message box.show autoval dot view plus auto. Some of these probably might need a toString, right? So which one's a toString? So let's just see what pops up first. Okay, this is so if you're not getting the data properly, use a toString. So in this case here, you'd probably want to use a toString because here is a int. So we go toString. Well, what other methods do we have here? We have, wow, we do have a compare to method which we haven't gone over. We have an equals method just like Java. Equals method and a compare to and a toString, which we've used a toString. Okay, so we may use a compare and equals method later on. So autoval.year.toString plus autoval dot sorry. What else do we have here? Autoval dot make don't need a toString on that. Then autoval, because that's a string, so autoval dot year dot toString. That should work. That should work, okay. So we'll print that out here. There's a lot of thinking involved, obviously, like in programming you have to think what you want to do and think what you're trying to do. So you have to think, okay, well, I want to do this, and how am I going to accomplish that? Well, I have to go through these steps. I have to convert these objects and these data types and pass the data around here and then there and all that. Okay, so we have 2007 forward with 1000, then 0, 0, 0, then some other, everything joined all together. Why do we have everything joined all together? Okay, let's try to figure out what we have here. Let's take these out, truck and car. Size 3. Okay, so we have our private automobile auto array. So private automobile auto array points at new automobiles. We're instantiating an automobile array passing in 3 different objects. Then we're setting everything to... Oh, I know why we printed it out twice. Okay, that's why. Let's try this, commenting this out. So then let's try that again and see what we get. So we should have one message box with everything in it, and then the rest should just be 0 with a null or something. The 2007 Ford 1000. Does that say 1000? Nope, I did 2007. Year, make, and year. That was wrong. Year, make, and mileage, my bad. Someone in the watching, one of the viewers is like, I knew he made that mistake. What an idiot. I know I'm an idiot. Trust me, I know. Okay, so here we have, let's try that again. So let me just run it, see what the output is. Okay, so 2000 forward and then 1000, all joined together, no spaces. First message box. Second message box is 0, 0, no spaces. Third one, 0, 0, no spaces. That's it. So no null was printed. I guess null didn't even show up, the null string, which was the make. It didn't even show up. Null never popped up. So that's just the way it was. Okay, so we're getting about half an hour here. So in the next video, we'll be going over storing structured objects in a list. So thanks for watching, guys. If you guys liked the video, you can like and subscribe to support the channel for more programming and investing tutorials. So in the next video, we'll be, I just said what we're doing, so we'll be going over lists and structures. Then we'll do a GUI example. So a lab, pretty much. So thanks for watching, guys. Hopefully I'll see you guys in the next one. Take care. Thanks.